Chapter 1.6, a library of parent functions. So in this chapter, we are mainly going to be dealing with writing equations of linear functions and also dealing with piecewise functions. However, I'd like to take some time to introduce 8 different common functions that you will see throughout the year in Precalculus. Okay, these are some of the most commonly used functions in algebra. So it's important to know the shape and characteristics of these functions, right? In the next section of the chapter, we are going to be taking all of these graphs and we will be transforming them. In other words, we're going to be stretching them vertically, horizontally. We'll be shrinking them vertically, horizontally. We will be shifting them up, down, left, and right. We'll be reflecting them over the x-axis and over the y-axis. So it's important that you begin now to just get an idea of what these functions look like, okay? So we have f of x is equal to c. That's our constant function. That's just a horizontal line. We have f of x is equal to x, right? That's just going to be a linear function. We have our absolute value function. Know that every absolute value function is going to have the shape of this v, or possibly an upside down v if we reflect this graph over the x-axis. We have our square root function, okay? I like to call this guy the swim move, right? If you imagine somebody throwing their arm out to do a swim stroke, that's kind of what it would look like. All right, we have our quadratic functions, which are always going to create some sort of nice parabola like we see here. We have cubic functions, reciprocal functions, and our greatest integer functions. Now, the one that you are probably least likely to see is definitely going to be the greatest integer function, these types of step functions. We won't be dealing with them this year, but if you do see them at some point in your math career, this is what they look like. So let's talk a little bit about linear functions. Okay, both the constant function and identity function are special types of linear functions. Writing a linear function is much the same as writing an equation for a line, but the function notation f of x is used instead of y. In order to write an equation of a line, you must have 2 pieces of information. You must have a point, and you must have a slope. And accordingly, as you guys hopefully know by now, my favorite way for writing an equation of a line is point-slope form. Y minus y1 equals m parentheses x minus x1. Okay, so let's see if we can't do a quick example. Now we're going to start off using this point-slope form. All right, this is a great way to begin solving for our equation of our line. And in the end, we are going to end up isolating y and then replacing y with the proper notation. That would be f of x, right? If it says use function notation, we definitely want to use the correct notation in our final answer. So it says write the linear function f such that it has the indicated function values. Well, we need to do some interpreting. What does this actually mean? F of -3 is equal to -8. This is telling me that when I plug in -3 into the function, I get out -8. Notice that the function notation is f of x, and so what's being replaced inside of the parentheses? A -3 is replacing the x. Therefore, -3 corresponds to the x coordinate. The output is going to be -8. This gives me the point -3, -8. Remember, if you're writing an equation of a line, you have to have a point and you have to have a slope. Well, what is this piece of information telling me? Again, the function notation is f of x. What are we replacing x with? 1. This tells me that when I plug in 1 for x, I'm going to get out 2 for y, leaving me with the ordered pair 1, 2. All right, now that we have 2 points, each and every one of you should be able to write the equation of this line. As we've talked about before, you have to have a point and you have to have slope. Don't forget these equations, this formula for slope, delta y over delta x. Let's take y2, which is 2, minus y1, -8, divided by x2 minus x1. All right, 2 minus a -8 gives me 10. 1 minus a -3 gives me 4. 10 divided by 4 reduces into 5 halves. There we have the slope of our line. Now we can come up with the equation of our line. And again, I strongly recommend that you guys learn to work with point-slope form. So we could pick either one of these points. I think a case could be made for either one. Notice that plugging in -3, -8, you'd have to work with positive numbers. Plugging in 1 and 2, you're working with smaller values. It's up to you. I chose the point 1, 2, leaving me with y minus 2 is equal to 5/2 x minus 1. One thing to make note of, okay, if the directions said write an equation of a line, I would accept this as a final answer. Okay. However, let's read the directions one more time. It says write the linear function f. That means that we want to solve for y and simplify everything else. Okay, and then we need to replace y with function notation f of x. So let's make sure we solve for y here. Okay, to do that, I would begin by distributing this 5/2 through. That gives me y minus 2 is equal to 5/2 x minus 5/2. And finally, to solve for y, I need to add 2. Adding 2, we need to get a common denominator. We could rewrite that as adding 4 divided by 2. And we know that -5/2 plus 4/2 is going to be -1/2. Now for our final answer, make sure we want to replace y with the proper notation. The directions say to write this linear function as a function f. Notice that was our notation that we used in the original part of the problem here. So let's replace y with f of x. F of x is equal to 5/2 x minus 1/2. There we have our solution. All right, let's try another one here. Write the linear function f such that it has the indicated function values. Now, again, f of 2/3 is equal to -5/2. All right, what is this telling me? When I plug in 2/3 for x, I get out -15/2. I can rewrite that as an ordered pair. The second piece of information is telling me that when I plug in -4 for x, I get out -11. That leaves me with the ordered pair -4, -11. Now, in order to write an equation of a line, we must have a point and we must have a slope. Well, notice here we have 2 points. Let's find our slope. Slope is equal to delta y over delta x. That's -11 minus a -15/2 divided by -4 minus 2/3. Now, again, whenever we are subtracting fractions, we need to get a common denominator. All right, to get a least common denominator in our numerator, I'm going to multiply -11 by 2/2, and I'm going to multiply -4 by 3/3. That leaves me with -22/2 plus 15/2 divided by -12/3 minus 2/3. Well, -22/2 plus 15/2 will give me -7/2, and -12/3 minus 2/3 gives me -14/3. I've got a fraction divided by a fraction. Now remember, whenever you are dividing fractions, rewrite it as multiplication. Rewrite it as multiply the denominator, all right, multiply by the reciprocal of the denominator. My denominator in this case is -14/3. I can rewrite that division as multiplying by -3/14. I just flip that bottom fraction. All right, -7/2 times -3/14. Notice that the negatives are going to cancel out and give us a positive. Now, multiplying fractions, we can multiply straight across. That will definitely work, but it'll give us some bigger numbers to work with when we try to simplify. One thing that we can do is we can kind of cross cancel here. All right, I've got a 7 divided by a 14. Well, how many times does 7 go into 14? It goes in twice, so I can cross out this 7, put a 1, cross out this 14 and put a 2, and now my multiplication becomes much easier, leaving me with +3/4. All right, so now that we have our slope, let's write our equation of our line. And again, the best way to do that is point-slope form. If you had to pick a point, I would probably go with this second point because then I don't have to work with the fractions. Could you pick the first one? Sure. But why make life harder? So we end up with y minus a negative 11 is equal to 3/4 parentheses x minus a negative 4. Again, if I asked you for an equation of a line, this would be a perfectly acceptable answer. But it says write the linear function. This means we must solve for y and replace y with f of x. So let's distribute our 3/4 through. And also notice that subtracting negatives is going to give us addition. So I have y plus 11 is equal to 3/4 times x plus 4. Distributing now, we have y is equal to 3/4 x plus 3 minus 11. And 3 minus 11, well, that gives us a negative 8. So going to our final answer, we are going to replace y with f of x. We get f of x is equal to 3/4 x minus 8. There you have writing linear functions. Again, start off, just write the equation of a line. That's a skill that you guys all have. Then isolate the variable y and replace y with f of x.